Before watching this video, please read the description. Crown XTi and XTi2 series amplifiers has important hardware bug. This bug is about signal limiter of XTi and XTi2 series. These amplifiers' signal limiter function is not working correctly and risking your speakers and destroying your sound quality. There's an input stage clipping event happening in the front end if input signal level just a little bit exceed to input sensitivity level. In this video I will show you how happening this problem on the old XTi 4000 model, but I did test it and I saw this same problem on XTi 2002 and XTi 4002 models in 2014. You can easily access the service manual of Crown XTi series on the internet. I didn't see any electronic circuit diagram difference between XTi 4000 and XTi 4002 models about the problematic section. Plus, if I'm not wrong, a few years ago I also tested a XTi 6002 model and I saw the same problem on it. XTi 6002 model is a completely different design. Outputs are Crown's famous Class I engine, power supply and DSP circuits are separate boards. I didn't test only XTi 1000 and XTi 1002 models, but I think there is same problem on it because that problematic section is same on all models, as you will see in the service manual. Before showing the problem, we need to understand what is the audio limiter function in audio power amplifier. It's very simple. If input audio signals level is exceed to sensitivity level of the amplifier for rated output power or output clipped threshold or user programmed level of output voltage, limiter must be able to compress the signal without distorting the signal. In general, audio mixers' main balance outputs can be deliver signal level up to 18 dBu or 20 dBu. Sine wave output without clipping. This means a power amplifier's input signal limiter must be able to compress the input signal up to 10.9 volts peak balance input signal level without clipping. In this case, it's not the reference how much small is amplifier's input sensitivity than 20 dBu. This is my edited screenshot picture from Crown XTi service manual. In this picture, all voltage values are calculated for CS4272 codec IC's datasheet, typical maximum input levels. And these pages are from the CS4272 datasheet. Be careful with the maximum input swing borders. You can pause the video here if you need to examine carefully. Back to the schematic again. If you bypass the all DSP functions and turn up gain port to maximum, at this point XTi 4000, also XTi 4002, input sensitivity level is 1.4 volts RMS for 4 ohm rated output power. As you can see, if input signal level is exceeds just a little bit to input sensitivity level, Crown XTi and XTi2 series amplifiers, limiter cannot do limit to input signal level without clipping in the front end, because as you can see, regional basic simple resistor divider calculations are wrong. There is no enough limiting range because at the input sensitivity level you are already used 73% of typical maximum input voltage voltage swing range of codec chip. Signal clipping is starting on codec chip when balance input signal level exceeds only calculated 1.91 volts RMS, but this level must be 7.74 volts RMS, least on balanced input. Your input sensitivity is 1.4 volts RMS, and your input front-end calculated clipping threshold is only 1.9 volts RMS. There is no range for limiting. This is a ridiculous mistake. Okay, let's start the test. If you have any Crown XTi or XTi2 series amplifier and a simple sine wave generator and lastly a basic simple oscilloscope, you can check this bug by yourself. For this very simple test, you don't need to a high performance, very expensive high-end signal source and high-end digital oscilloscope. You can check this bug by yourself with very cheap equipment. In this test setup, my oscilloscope's channel 1 is connected to U5 pin 1. Channel 2 is connected to U2 pin 17. Channel 3 is connected to U2 pin 25. And lastly, channel 4 is connected to amplifier's channel 1 output. All scopes channels are referenced to signal ground. Firstly, on the PC control software, I set the amplifier's output limiter level to somewhere far away from the output VCC rail clip level. For this, I choose approximately half of rated output voltage capacity of the XTi 4000 and I set threshold to -6 dB, as you can see in this window. If you have a XTi2 series amplifier, you will see this limiter window on the PC control software. An example, if you have a XTi 4002, you need to write approximately 34-35 volts on here in this window for the same setting as XTi 4000. All other DSP functions are off. For other XTi2 models, you can calculate the voltage level by yourself. On this test, there is no lot on the output. It's not necessary for this test, and also you need set fast attack and slow release time for soft clean limiting on XTi2 series. Now I am applying 1.91 volts RMS 1 kHz sine wave signal to balanced XLR input of the amplifier, and I set channel 1 gain pot to maximum level of the amplifier. At this point, amplifier's input sensitivity is 1.4 volts RMS, and as you can see, everything is normal now. Limiter is working correctly. There is no clipping on the signal yet. In this case, limiter is compressing the signal more than 50% because of the current limiter settings. This is U5 pin 1 XLR input balance to unbalanced converter op-amps output signal. This is U2 codec chips pin 17 input signal, positive input signal, and this is same codec chips pin 25 positive output signal, and this is amplifier's channel 1 output signal. We are looking at only positive side of the balance signal path on the codec chip. I only set channel 3 to AC coupling, all other channels DC coupling, and I put 20 MHz bandwidth limit on all channels for making a little bit more clean waveform wave. Also, sampling rates and memory depth settings absolutely okay for this waveform. And I choose top, base, and amplitude readings. Because these readings are more reliable than positive peak, negative peak, and peak-to-peak readings on this test only, because this is a switch mode amplifier and little bit switching noises on the signal, and we have very simple basic sine wave signal. In this case, for this test, top reading is equal to positive peak, base reading is equal to negative peak, and amplitude reading is equal to peak-to-peak reading. There is one more thing. This is be careful with the amplifier's output scale. This is 60 volts division. This is XTi 4000 model amplifier, and this amplifier's maximum peak output voltage capacity is approximately 100 volts peak, and we are only 52 volts. We are very far away from VCC rail clipping point, VCC rail clipping threshold. And you, in this video, you will never see VCC rail clipping on the amplifier's output signal. Be careful with that. And we have 1.91 volts RMS, and remember, this level is maximum input level of this amplifier without clipping. Now I'm going to 2.0 volts. There is still clean, maybe a little bit, but that's okay. And also this limiter level is okay. This must be 34-35 volts, but only approximately 2 volts error. That's okay, that's normal. Peak level is correct. 2.0 volts, still clean, still there is no visible clipping. I'm going to 2.1 and it's S. Now clipping is started on the output signal, because codec chip's output signal is started clipping, because codec chip's input signal level is out of the range now, out of the maximum input swing range of the codec chip. Be careful with these readings. 4 volts, top 4 volts, base 1 volts, and 2.9 volts amplitude. Compare these readings with that CS4272 datasheet. Now input is clipping. Codec chip's input is clipping. This is why output is clipping now. I'm going to 2.2. Yes, it's more visible now. 3, 2.3, 2.4, 5, 6, 7, 8, 9, and 3.0 volts. As you can see, amplifier's output signal is clipping because codec chip's output is clipping and codec chip's input going to ridiculous points. Codec chip's input is clipping. If I go to 4.0 volts, I rescale to channel 1 again. As you can see, also plus codec chip's input signal is started clipping because there is input swing, over swing protection in the codec chips, and that protection is clipping the waveform now. I'm going to 5 volts RMS, this is 5 volts RMS, and 6 and 7 volts RMS. This is disgusting. Remember, if your audio mixer can be delivered up to 20 dBu signal without clipping, this value must be 7.74 volts RMS without clipping. And look at this waveforms. And there is nothing, there is no any clip indication front of the amplifier. Display says nothing and clip indicator says nothing. And Crown XTi and XTi2 series users will never know if their signal is clipping. Also, PC software is saying nothing about this clipping. This situation, this clipping situation is destroying your sound quality and creating extra heat stress on your loudspeakers, and it's risking your high frequency drivers dependent how much input signal is clipping. And I report this problem with an email to Crown, but they didn't care. They say to me, there is only person you feedback this. There is no problem on it. That's all. They didn't care. But look at this thing. Okay, what is the solution for this problem? There are multiple solutions. First option is for fixing the problem, it needs to only one resistor value changing on each channel, and plus DSP firmware update is necessary for new input sensitivity of codec chip. But there's an important detail about this. This is most easy way to fixing the problem. But this modification is probably will increase the noise level of the amplifier. If you want to fix the problem and plus catching the best THD plus noise performance as possible, it needs to a few resistor value changing on each channel, and plus DSP firmware update is necessary, of course. But this is impossible for me because I am not a software engineer. I can't write a new firmware for this. Only Crown can do this, but they don't care, unfortunately. This is second option for fixing the problem. This block diagram shows what I did in 2014. This is block diagram of my hardware modification. I did 3 resistor values change on each channel. Here I divide input signal by 4 before the codec IC and multiply by 4 again after the codec IC. This modification is creating plus 12 dB more voltage range on codec IC without changing regional sensitivity level of the amplifier. With this modification, amplifier's limiter is working correctly and it's working without input clipping up to 10.8 volts peak calculated balanced input level. I tested this with 10 volts peak sine wave input and there's no problem. But I will not say to you what resistors I change here because I don't recommend this modification. In this modification, limiter is working correctly and compressing the signal without clipping up to 10.8 volts peak. But there are 4 important problems comes with this modification. Problem number 1 is front panel signal level Vmeters are not working correctly because regional DSP firmware is not compatible with this modification, of course. Problem number 2, for regional firmware, you need to set to divide by 4 of output limiter voltage threshold value. An example, if you want to 60 volt output limiting, you need to set to limiter threshold to 15 volts on the PC control software. Problem number 3, high noise level. In this modification, amplifier's noise level going to annoying level, of course. In 2014, I had to find something immediately for fixing this problem without extra costs, and I did this modification. I was driving subwoofer with an XTi 4002 amplifier, and this high noise level doesn't matter for subwoofer, and I did this. And problem number 4, if another person will use the amplifier who don't know this modification inside the amplifier, he will set to limiter threshold to very wrong point, and this will be catastrophic. This is why I don't recommend this modification. And lastly, this is option 3 for fixing the problem. This is what I recommend to you. Do not use limiter function of this XTi and XTi2 series amplifiers. Do not modify anything inside the amplifier. Go and buy an external limiting device like another audio DSP or limiter and put it between signal source and the amplifier. Of course, this option means more cost to you. At this point, probably you will think about buying another brand model amplifier with correctly working.